Find the Fourier series for the function f of x equals minus pi for x belonging to the range open interval minus pi to 0 and f of x equals x for x belonging to the range open interval 0 to pi. Deduce the result 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus etc. equals pi square by 8. Here our function displays minus pi as the output for input values x belonging to the range open interval minus pi to 0 and function displays the output x whenever input values x belong to the range open interval 0 to pi. We have the general format of interval considered as c comma c plus 2l. Thus we have c equals minus pi here and c plus 2l equals pi. Considering the complete interval minus pi to pi, we will get L equals pi. Thus we have the Fourier series representation given by f of x equals a0 by 2 plus summation n ranges from 1 to infinity applied on an cos nx plus bn sin nx. We have a0 evaluated using the formula a0 equals 1 by pi integral f of x dx, where we have to split integral f of x dx to two open intervals minus pi to 0 and 0 to pi. In the range minus pi to 0, we have f of x equals minus pi, and in the range 0 to pi, we have f of x equals x. We have minus pi is just a constant which can be taken outside process of integration. Thus, we have a0 equals 1 by pi times integral minus pi to 0 dx once minus pi is taken outside integral plus integral 0 to pi x dx. Integral dx equals x and integral x dx equals x square by 2. Giving the upper and lower limits for both the integrals, we will get a0 equals 1 by pi times minus pi square plus pi square by 2. On simplification, we will get a0 equals minus pi by 2. We have an evaluated using the formula an equals 1 by pi times integral f of x cos nx dx. Here we have to split the integral f of x cos nx dx to two integrals, integral minus pi to 0 f of x cos nx dx plus integral 0 to pi x cos nx dx, where 1 by pi is common to both the integrals as in the previous case. We have integral minus pi to 0 minus pi cos nx dx equals minus pi times integral minus pi to 0 cos nx dx. We have integral cos nx dx equals sin nx divided by n, to which we will give upper and lower limits 0 and minus pi respectively. But we have sin 0 equals 0 and sin n pi also equals 0. Thus this integral will become 0. While integrating integral 0 to pi x cos nx dx, we can make use of integration by parts. First function x is written as it is, integral cos nx dx equals sin nx divided by n. Now we differentiate x, which will give 1 as the answer. We have integral sin nx divided by n is obtained as minus cos nx divided by n square. We have to make use of negative sign here because of alternate signs to be used. Giving x equals pi or x equals 0 to this term, it will give 0 as the answer. This term becomes positive when you multiply minus into minus, and this is the only term which will give you a non-zero answer. Giving the upper limit x equals pi, we will obtain cos n pi divided by n square. Giving the lower limit x equals 0, we will get 1 by n square. Thus we get an equals 1 by pi n square multiplied to cos n pi minus 1, where cos n pi equals minus 1 the whole raised to n. Giving different values for n equals 1, n equals 2, n equals 3, etc. We will get a1 equals minus 2 by pi, a2 equals 0, a3 equals minus 2 by pi into 3 square, and so on.